Hello everyone, Namaskar, welcome to Maths Guidance. We have successfully completed up to 8 chapters and we are now in the ninth chapter. This will be the first lecture, first video of chapter number 9, and the chapter's name is Areas of Parallelograms and Triangles. Okay, so Areas of Parallelograms and Triangles is the name of the chapter, chapter number 9, and in this chapter we are not going to calculate the magnitude of the area. Alright, we are going to study the relationship between such geometric figures like parallelograms and triangles under some conditions, and the conditions are these should be on the same base and between the same parallels. All right, so this is not a very big chapter. Hopefully in 4 or 5 lectures we will be able to complete it. So let's start the chapter number 9, new chapter, and very good chapter, very interesting chapter. And okay, let's start the chapter. Thank you very much. So let's start this chapter, areas of parallelograms and triangles, and let's start with an introduction of areas. Okay, let's understand something about areas. So let us suppose we have been given two triangles or two figures like this. Two figures we have. This is figure A and this is figure B. All right. So, and these two are congruent. So if these two are congruent, that means these two will superimpose each other. If you put this one over this, then it will cover wholly, completely. So basically these two are congruent, and if these two are congruent, that means its areas must be equal. So if two figures are congruent, are congruent, then its areas must be equal. Its areas must be equal. All right. If the two figures are congruent, so they must have equal areas. But if you make the converse of this statement, that if two figures having equal areas, then these two figures are congruent, then that is not true. The converse is not true. Let us write the converse. If two figures are having equal areas, then the two figures are congruent. This is the converse, but this is not correct. It's a false statement, and we will understand it through an example. So this is a right statement. If two figures are congruent, then its areas must be equal. So these two triangles will have equal areas. But the converse, if two figures are having equal areas, then the two figures are congruent. This is not true. This is false. So we are not going to. Okay. Now let's understand how we can say this. Suppose we have two figures. One is a rectangle. Okay, like this. And one is a square, like this. Now let us suppose this is 4 centimeter and this is 16 centimeter. Okay, this is 8 centimeter, this is a square, so all the sides will be equal 8 centimeter. Now this is figure A, this is figure B. So area of A, in short we'll write like this: area of A equal to 16 multiplied by 4, area of rectangle equal to length into breadth, that is equal to 64 centimeter square. Now let us see area B equal to, it's a square, so 8 square, that is equal to 64. So you see the areas are equal, but the figures are not congruent. Okay, this is what the converse says. If the two figures are having equal areas, then the two figures need not be congruent. Basically this is the converse. Okay, then the two figures I have written because I had to show that this is a false statement, but the converse is not true. So we cannot write the converse. It is not true. Okay, converse of this statement is not true, and we have understood it through this example. that one is a rectangle, one is a square having same equal areas, but these two are not congruent. All right. Now, if the two figures are not congruent, then let us see through one example. Let us have study this figure. This figure is divided into two parts like this. This is one part, and this is another part. Let us suppose this is part A, this is part B. So if we have to find the area of this figure, what will we do? Let us suppose this is T. So area of T will be equal to area of A plus area of B. We can simply write like this: area of figure T is equal to area of figure A plus area of figure B. Okay, because these two figures are not congruent, we cannot write twice area A or twice area B. These are not congruent, these are different figures. Like in this figure, it is congruent, and this is not congruent. These two are not congruent. So basically, we have two scenarios when the two areas are equal and when the two areas are not equal. Okay. Now, let's move forward and let's understand the relationship between the areas of such geometric figures under what I said in the start, the condition that they will have same base and between the same parallels. Okay. So this was the introduction about areas, and I hope everything is clear. Now let's move on. So let's study first the figures on the same base. Okay, and let's study the combination of some figures, different figures. So first of all, let us suppose this is the base. Okay, first of all, let us draw one trapezium like this. All right, and let us draw one parallelogram like this. So basically, A, B, C, D, E, F. This is one figure. Okay, let us draw the second figure like this. Both are the parallelograms. M, N, O, P, Q, R. Alright, this is figure 2. Now let us draw figure 3. Figure 3 is a combination of two triangles like this: A, B, C and D. This is figure 3. Let's draw one more combination of one parallelogram and one triangle. One parallelogram and one triangle. Let us suppose this is E, F, G, H and I. This is figure 4. Now let's study all these figures. Figure 1 is there is one trapezium and one parallelogram. So trapezium ABCD and parallelogram EFCD both are on the same base CD. So the base is same. Okay. So figure 1, trapezium ABCD and parallelogram EFCD are on the same base that is CD. Okay, let us understand this second one. Second one figure, there are two figures, both are parallelograms, MNOP and QROP. Both are parallelograms on the same base OP. Okay, both parallelograms, we can write like this: both parallelograms MNOP and QROP are on the same base. What is the base? Same base OP. Okay, so this was second. Now third figure. Third figure, it is having two triangles ABC and DBC. Two triangles ABC and DBC on the same base BC. Okay. Now let us see this one. Parallelogram EFGH and triangle IGH. Parallelogram EFGH and triangle IGH are on the same base GH. Okay. Parallelogram EFGH and triangle IGH are on the same base GH. Alright, so basically these figures are having the same base CD. Here CD, here OP, here BC, here GH are having the same base. Two figures are lying on the same base. So this is one of the cases, figures on the same base. Now let's study figures on the same base and between the same parallels. Okay, so now let's move on. So now let's study this topic, figures on the same base and between the same parallels, which we have to study finally. Let's draw some figures. Like first one, let's draw. Let us suppose this is in the same way, this is a trapezium. Okay, ABCD, and this is a parallelogram. Okay, this is a trapezium ABCD and parallelogram EFCD. First one. Okay, so let's study this first figure first, then we will move on to second figure. So the trapezium ABCD and parallelogram EFCD are on the same base, but in addition to this, if you see it closely, if you monitor it, you will find that in addition to this, these are also on between the same parallels. This parallel AF. Okay, suppose this is a line parallel AF, if you like extend like this AF. So AB and EF, they are on the same line. So basically these two figures are between the same base, on the same base, and between the same parallels AF and DC. The same base is CD, same base is CD, and between the same parallels AF and CD, that is between the same parallels, So these are the figures which are having the same base and lying between the same parallels. Its vertices AB and EF are lying between the same parallels AF and CD. Alright. Now let's see one more figure. Let us see one more figure like this. Let us suppose this is a parallelogram and one more parallelogram like this. Let us suppose this is A, B, C, D and EF. So we are having two parallelograms ABCD and EFCD, and the same base is again CD, same base is CD, and these two parallelograms are lying on between the same parallels AF and CD. You see, its vertices A and B and E and F are lying on the same line. Okay, AF. So between the same parallels AF and CD. We are having two parallelograms here, parallelogram ABCD and parallelogram EFCD. Okay, and here we had one trapezium ABCD and parallelogram EFCD. Okay, now let's understand one more figure having two triangles. Like let us suppose this is one triangle, and let us suppose this is another triangle. Let us suppose this is CDE, this is P. So one triangle is CDE, another triangle is PDE, having the same base DE, same base DE, and between the same parallels CP and DE, CP and DE, the same parallels, between the same parallels. Okay, this vertex lies on this line CP, this vertex also lies on this line CP, so between the same having the same this line, between the same parallel CP and D. Alright, now let's study one more figure having one parallelogram, this is the parallelogram, and having one triangle MNOPQ. So one parallelogram MNOP and the triangle is POQ, having the same base PO, between the same parallels MQ, between the same parallels MQ and PO, this line and this line. Okay, between the same parallels, here also between the same parallels, here also same, here also same. So basically these are the figures having the same base and between the same parallels. Okay, I hope everything is clear now. Now let's move on. Now let's see the let's write it what we have just now studied. The definition will be like this, that two figures are said to be on the same base and between the same parallels if they have a common base and the vertices or the vertex, in case both are triangles. Okay, if they have a common base and the vertices opposite to the common base of each figure lie on a line parallel to the base. This will be the definition. Now let's understand some more figures to understand it clearly. Let us suppose this is a base, okay, and this is a triangle like this ABC. This is one more triangle DBC, okay, and this is the line. Let us suppose this is a line L. Can we say that these two figures, these two triangles lie on the same base and between the same parallels? No, we cannot say, because the base is same, alright, but the vertex A and vertex D, they don't lie on the between the same parallels. This is one line L and this is BC, so it is lying somewhere different than this line. Okay, so this is not lying on the same base and between the same parallels. Alright, let us see one more figure. The figure is like this. Let us suppose this is a parallelogram and this is a different parallelogram. You can name whatever you like, MNOPQR. So these two parallelograms MNOP and QROP lie on the same base PO, but not between the same parallels, because here it is different, here it is different. It is MN and it is QR. Alright, these are two different lines. So this is also not a figure having the same base and between the same parallels. These two are not the same. Now let us see one more case. This is like this, A, B, C, D, E, F. If you see this these two figures, here it is having two parallelograms, one is ABCD and one is EFCD. Okay, the base is same DC, but the vertices are on different lines. This AB is having this line, EF is having this line. Okay, so these two figures don't lie between the same parallels. Now if you see the figure from here, from this base, you can see this is the base, common base. One is this parallelogram, one is this parallelogram. Okay, here again the problem is that the base it is CB, but this parallelogram is having CF. So base is also not common. These vertices are lying on the same parallels, but this base is not common. Okay, so this is also not a definition of the figures having on the same base and between the same parallels. So the main condition is at least one line, or out of the two parallels at least one must be the line containing the common base. Okay, these are the two lines between the same parallels. If we say, so one line must be the common. This is not common, this is having CF and this is having CB. Okay, so that is why we cannot say this as a figures having same base and between the same parallels. Okay, so the condition is that out of the two parallels, one must be the line containing the common base, okay, this is the condition. Here it was a common base, but these figures were not between the same parallels. Here it was a common base, but these figures are not between the same parallels. Here the situation was different, but it is also not lying between the same parallels. Okay, now I hope everything is clear, and let's take some questions also, some more questions to understand this clearly. Now let's see this question. This is from the NCERT textbook, exercise 9.1. Question is, which of the following figures lie on the same base and between the same parallels? In such a case, write the common base and the two parallels. Okay, so we have been given 1, 2, 3, 4, 5, and this one 6. This one is 6, number 6. 6 questions we have. So first of all, this figure 1, it is having one trapezium and one triangle on the same base CT and also between the same parallels AB and CD. So we have to write the common base. So common base is CD. And the two parallels we have AB and CD. It is clear. Two parallels AB and CD. So this is a figure. These two, one trapezium, one triangle, are lying on the same base and between the same parallels. Alright. Let's come on the second figure. The base is okay, SR, but not between the same parallels. Here the line is different. Okay. So this will not be a case. Now the third one, if you see, if you take this base QR, so one will be a parallelogram PQRS and one will be a triangle TQR or RTQ, whatever you can write, but the base is this and the parallels are this. So common base is, so basically this is a figure. Common base is QR and the two parallels are QR and PS. Alright. Now let's consider this one. If you take this base, so between the same parallels, this triangle and this parallelogram are lying between the same parallels AD and BC, but the common base is not the common. It is having PQ and it is having BC. So this will not be a case. Okay, I had told you in earlier section that this is not a case. At least the common base should be common to both the figures. Let's understand this one. There are having two parallelograms ABCD like this, ABCD and APQD. Okay, so the base, let us suppose this is the common base AD. This will be a figure. Common base is AD. And the two parallels are AD and BQ. Because these vertices lying on the same line. Okay, so this will be a figure. Now let's consider this one. this cannot be a figure between the same base and between the same parallels, because this ABCD is lying somewhere. If you take any this is, and these are not common, AB and PQ are not common, DC and this is not common, so it will not be a case. Okay, by looking at the figure you can tell this is not a case, because nothing is common, base is also not common. Alright, parallels is okay between the same parallels, but base is not common. So I hope everything is clear now, and we will move on to the next topic in the next lecture. Okay, so friends, we have studied figures on the same base. First of all, we have studied figures on the same base, and then we studied figures on the same base and between the same parallels. All right, we saw different combinations having parallelogram, trapezium and triangles also. You can have different figures also, squares, rectangles, you can have on the same base and between the same parallels. And we saw the minimum condition of having this criteria is that the line or the base should be common, at least base should be common, one line should be common. So, and we saw different problems also, how to identify the figures having same base and between the same parallels. So I hope this topic is clear, and we will move on to some theorems now in the next lecture, video number 2 of this chapter. Okay, so please stay connected to my channel, to my videos, and please like, share and subscribe my channel. Thank you very much.